Hi, and welcome to Allen High School's discussion of electrochemistry at the AP IBHL1 level. We're working on some variety of different problems, electrochemical cells and so forth. And so let's take a look at this one. Important, you want to underline these. An electrolytic cell. That means we're dealing with a situation that is not spontaneous. Now, I have a current of 0.25 amps. And I have an iron chloride. Now, hopefully you can guess that I have either FeCl3 or FeCl2. Right? It's not absolutely crucial yet for the question, but if your mind can go that direction, it will help. Now, I'm producing the metal. So that means I'm either taking Fe3+ plus 3 electrons and going to Fe, or I'm going to Fe2 plus 2 electrons going to Fe. Either way, these are both reductions. So the question asks me, what is going on at the anode? Well, the other solution, the other possibility here is told to us. Now, honestly, we have a choice. Since we have water, the oxygen from water could be oxidized, or the chloride ion could be oxidized. Now, you would look at your redox table to predict if you needed to. They're very close to one another. Fortunately, we don't need to because the question tells us that chlorine is produced. So that means that the answer to this question is that 2 chloride ions will be oxidized to form chlorine gas plus 2 electrons. So that would be what is happening at the anode, because remember, oxidation takes place at the anode. Now, we have a time and a mass, and the question is, which substance do we have? Do we have FeCl3 or FeCl2? Now, there's a couple of ways that you can do this. I'm going to set up our dimensional analysis. Both involve dimensional analysis, by the way. All right, and I'm going to start with my 2 hours. Now, one of the keys to doing these is to remember that 0.25 amps is the same as saying 0.25 coulombs for every 1 second. That's one of the 2 things that are critical. So I have to get this to seconds. So 3,600 seconds per 1 hour. So now I have seconds. I can go to coulombs. And I have 0.250 coulombs per 1 second. That's where you use your amp. Now, the second key thing to remember is that it is Faraday's constant. That is our link between the world of electricity and the world of chemistry. So for every 1 mole of electron that goes through, we have 96,500 coulombs. Now, this is the tricky part. We have 1 mole of iron formed for every X moles of electrons. We don't know. We don't know what it is, all right? And then we need grams, all right? So there's a couple of ways you could do this, all right? But I'm going to go ahead and do it this way. We've got 55.85 grams, and it's per 1 mole. Now, the problem tells us that we make, when we do this, this is equal to 0.521 grams. So, 2 ways you can do this. Plug in a 2 here and see if I get 0.521, then plug in a 3 here and see if I get 0.521, or just solve this math equation for x. Either way, we find that x is equal to 2. So that means I have this at my cathode and this at my anode. They both involve 2 electrons, so I don't need to multiply either by a balancing factor, even though I was about to mess that up there. That should be a 2 plus, not 3 plus. So I have Fe2 plus 2 chlorides yields Cl2 plus Fe would be my balanced equation. Okay, so this was a little odd. Usually that your final mass is the unknown, or maybe your final time is the unknown. This time it was the moles of electrons that was our unknown. Okay, I've got a question asking me volume. I have a gas, I have temperature, I have pressure. Hopefully by now you can do PVNERT. I am not going to spend time on that. The answer is 0.231 liters. And we'll go on. Now this one says calculate the current at 3 grams per 1 hour. So it's again a dimensional analysis. For current, remember, is coulombs per time. So I'm going to put time in the denominator. I have 3 grams and I have 1 hour. Now I need to get this to coulombs per second because that's what an amp is. Now if you wanted, you could take grams to coulombs and then divide by time at the end. Whatever you want to do this. This is Cl2. So 1 mole per 70.9 grams. Now we've already discussed the fact that it's now 2 moles of electron for every 1 mole of chlorine that is formed. Now I want to get rid of moles of electrons and go to coulombs. And that's where we have our bridge between the world of chemistry and the world of electricity. Okay? Now, if I stopped my math, I'd have coulombs per hour, but that's not what an amp is. An amp is per second. So I have to convert 1 hour to 3,600 seconds. Now, you could have done that separately and then just divided by the number of coulombs. And once you had coulombs from the first part, then divide by seconds at the end. Either way, you should get 2.27 amps or coulombs per second. Okay, so that is one of those dimensional analysis. I'm going to skip over this because I only want to do one more of these types of reactions. And I think I'd like to go to this one with the unknown in it. So we have an unknown cell, or I have a galvanic cell. Let me make sure I have the right one here. Okay, here we go. This is the one I want. I have an unknown metal, M, and it forms a soluble compound, MnO3 So I know that my metal has a charge of 2 plus. How do I know that? Well, nitrate's -1, so that metal must be +2. And again, this is another one of those types of dimensional analysis, stoichiometry. I want to identify the metal. To identify the metal, I need to determine its molar mass. So I need to take the grams and divide it by the moles of metal. So it gives me the grams. All I need to do is find my moles. And I can find that based on the electrolysis. So I electrolyzed for 35 minutes. Now, my amp is 2.5. Remember, that's the same thing as a coulomb per second, equivalent to 1 second. So let me get my minutes to seconds. Better not put that. It looks too much like meters. Now, instead of putting amps, this is key to this, is recognizing that an amp is that many coulombs for every 1 second. So now I have coulombs. I need to get into my world of chemistry, so it's 1 mole of electrons for every 96,500 coulombs. So coulombs cancel, seconds cancel, minutes cancel. Now, I do know, because this is Mn2 plus, or metal 2 plus, that I'll get 1 mole of my metal for every 2 moles of electrons that are pushed through. So the mathematics tells me I have 0.0272 moles of metal. So now if I plug that into my molar mass equation, I take the grams that were given, I divide it by the moles, 0.0272, and I get a molar mass of 112.5. Okay. Now, if I look on the periodic table, the metal that has a molar mass of this many grams per mole is cadmium. So the identity of my metal is cadmium. Okay. Now, if you did not want to hop out of this, you could have done what we did in the last problem, and I could have had an X for the molar mass equal that many grams, and I could have solved for the molar mass. So however you want to do that, that's fine. Okay. Okay, so I've got this metal now. This is cadmium, and this is zinc. And it tells me it's a galvanic cell. You need to know that a galvanic cell is a spontaneous voltage-producing cell. Cadmium's voltage, E naught, is 0.40, negative 0.40. Zinc is negative 0.76. In a spontaneous cell, you make the most positive one. I can't even spell spontaneous, sorry. I make my most positive one be my reduction, and the most negative one be my oxidation. So that means zinc is going to be oxidized, cadmium is going to be reduced. They both involve 2 electrons. So I'm going to do this part pretty quickly because we've seen this. So cadmium gets reduced from cadmium 2+ to cadmium metal. Whoops. And zinc is oxidized from zinc metal up to zinc ion. And my E naught, I've got to flip the sign of the zinc since it's an oxidation. So it's 0.40 plus 0.76, which is 0.36 volts. All right, in the next part, it asks us what is the free energy at 25 degrees Celsius. Well, delta G naught, you have this formula, is minus NF E naught. There are 2 electrons involved. This is moles of electrons. There are 2 electrons involved. Faraday's constant, E naught, 0.36. All right, and I only know that 0.36 to 2 significant figures. So my final answer is minus, it better be negative because it's spontaneous, right? Positive E naught is spontaneous, negative delta G naught is spontaneous, and I end up with negative 69 kilojoules, right? This actually gives me minus 69480 joules, and when I round that and convert to kilojoules, I get minus 69 kilojoules. Now, it says what's going to happen if I change the molarity of one of them. It actually says calculate, not predict. You can predict if you want whether it will go up or down. I have cadmium ion plus zinc, yielding zinc ion plus cadmium. Now, and plus voltage, right? This is spontaneous voltage producing. Now, what I did is I decreased my zinc ion concentration. So if I decrease my zinc ion concentration, Q is my zinc ion over my cadmium. If I decrease this, my Q's too small, and I need to shift to make more products to make it larger. So my voltage should be higher than the 0.36. So I expect my E to be greater than 0.36 volts based on Le Chatelier's principle. But this would have been in a calculator section. So we're going to go ahead and calculate it too. Minus 0.0591 or 0.592. I have seen both, kiddos. I'm sorry. I happen to have 0.591 here. Natural log, my zinc is 0.1, and my cadmium is 1, and if I do that calculation, I get 0.39 volts, which was indeed higher than the other one. Okay, so gives us a couple to work with. If I get more time before the test, I'll put a couple of more up before then. But until then, this is signing off.